You ever just pick up a rock and kind of wonder, what's its story? It might look like just a chunk of stone, right? But believe it or not, every single one of them has this epic story to tell. A biography, really, written by fire, water, and just incredible pressure over millions and millions of years.
So that's what we're going to do today. We're going to read that biography. We'll kick things off with the basics, then dive into the three big rock families. That's igneous, sedimentary, and metamorphic. And then we'll see how all their stories weave together into this amazing, never-ending cycle. All right, let's jump right in at the beginning.
All right, first things first. What even is a rock? I know it sounds super obvious, doesn't it? But geologically speaking, the definition is actually really simple and kind of beautiful.
Okay, so here it is. A rock is just a naturally occurring bunch of one or more minerals. The key word there is aggregate. Think of it like a chocolate chip cookie. The minerals, they're your ingredients, the flour, the sugar, the chocolate chips. The rock is the finished cookie with all those bits and pieces stuck together.
Now, when geologists look at rocks, they sort them into three big families. And what's interesting is it's not based on what they're made of, but on how they were formed, how they were born, basically. Each family is like a whole different chapter in a rock's life. So let's get into chapter 1.
Our story kicks off deep, deep inside the Earth. We're talking about a world of insane heat, just full of molten rock. And this is the forge, the birthplace of our first rock type, igneous.
You see, all brand new rock starts its life as magma. That's just the fancy word for molten rock when it's still underground. Now, when that stuff erupts onto the surface, say from a volcano, we call it lava. And as this super hot liquid starts to cool, it hardens and crystallizes. And voila, you've got an igneous rock. But here's the kicker. How it cools changes everything.
It all comes down to speed. How fast does it cool? If the magma cools really slowly, deep underground, we call that intrusive. Because it's slow, the minerals have plenty of time to get organized and grow into big, beautiful crystals. It's just like making rock candy, right? You let the sugar water cool slowly and you get those huge crystals. On the other hand, if lava cools super fast on the surface, that's extrusive. The crystals have basically zero time to form, so you end up with tiny crystals or sometimes none at all.
And you can totally see this difference out in the world. That slow, cooling, intrusive stuff, that gives you something like granite, the stuff in kitchen countertops, with all those big, sparkly, visible crystals. The fast-cooling, extrusive rock, that's more like basalt, which is much more fine-grained. And what if it cools almost instantly? Well, then you get something like obsidian, which is basically volcanic glass. No crystals to see there at all.
But okay, a rock's story doesn't just stop after its fiery birth. No way. Over time, all the forces on the Earth's surface, wind, rain, ice, they start to break that rock down. And that kicks off a whole new chapter, the story of sedimentary rocks.
This whole chapter is really a story about recycling. It starts with an existing rock, any rock, getting broken down into tiny pieces. We call those pieces sediments. Then, wind, water, or ice picks up these little bits and carries them off somewhere else. Eventually, they get dropped off or deposited, usually in layers at the bottom of a river or an ocean. And then, over thousands and thousands of years, the sheer weight of all the layers on top squishes them together, while minerals in the water act like a natural glue, cementing everything into a brand new rock.
And because of how they're made, sedimentary rocks are basically Earth's history books. For real, you can often see these beautiful layers. They're called strata, which show you different moments in time. And get this, they're the only type of rock where you can find fossils. They're like little time capsules, preserving clues about ancient plants and animals, and even telling us about oceans that aren't there anymore. Plus, all those little spaces between the grains make them porous, which is super important because that's where things like groundwater and oil get stored.
Okay, so rock can be born from fire, or it can be made from a bunch of broken pieces. But what happens if you take one of those existing rocks and subject it to some serious, and I mean serious, stress? Well, it gets a total makeover, a complete transformation, and that brings us to chapter 3.
This process is called metamorphism, and the absolute key thing to remember is that the original rock gets baked and squeezed so hard that its minerals literally change. But it doesn't melt. It's a fine line. The best analogy is baking bread. You start with dough, you add heat, and you get bread. Something totally different, right? But the ingredients are all still there, they've just been transformed.
So what kind of forces are we talking about here? Well, there are three main culprits. First, you've got intense heat. either from being buried way down deep or from being too close to some magma. Second, immense pressure. Think about the weight of miles of rock pressing down, or even entire continents crashing into each other. And third, you've got these chemically active fluids, basically super hot water full of dissolved minerals that can seep through the rock and totally change its chemistry.
A lot of the time, that intense pressure squishes the rock from a certain direction, and it forces all the little mineral grains inside to line up, kind of like soldiers in formation. This creates a cool layered or banded look that we call foliation. Gneiss is a perfect example of this. But if the pressure comes from all sides equally, or the original rock was simpler, the minerals don't line up. You get what's called a non-foliated rock, like marble. And fun fact, marble is just what you get when you metamorphose limestone. And to see just how wild this transformation can be, just look at what happens to a simple sedimentary rock like shale. You add a little heat and pressure, low-grade metamorphism, and boom, it becomes slate. Turn up the dial a bit more, and that slate morphs into schist. Crank the heat and pressure all the way up to high grade, and you get that beautifully banded gneiss. It's the same starting material, just completely reinvented at every single step.
So there you have it, the 3 main chapters in a rock's biography. Born from fire, rebuilt from pieces, and totally transformed by pressure. But here's the most mind-blowing part. These aren't separate stories, not at all. They are all connected in one massive, continuous, never-ending loop.
And that's the whole idea behind the rock cycle. Think about it. Any rock can become any other kind of rock. That igneous rock born from a volcano, it can get worn down by rain and become sand, which then becomes a sedimentary rock. That sedimentary rock can get buried deep underground and get cooked and spreezed into a metamorphic rock. And that metamorphic rock, it can get pushed so deep it melts back into magma, and the whole process starts all over again with a new igneous rock. It is literally the planet's ultimate recycling program.
So, next time you're out for a walk or on a hike and you pick up a rock, I want you to really look at it. Is it a speckled piece of granite, a layered chunk of sandstone, a wavy piece of gneiss? Don't just see a stone, because you're actually holding a chapter from Earth's own autobiography. The real question is, what story is it telling you?